Crop diversity and climate resilience building food security in a changing climate. Agriculture is entering a period of unprecedented change. Around the world, farmers are facing rising temperatures, shifting rainfall patterns, more frequent droughts, floods, storms, and the growing spread of pests and diseases. These environmental changes are affecting agricultural productivity and creating new risks for food systems that support billions of people. Crop diversity and climate resilience building food security in a At the same time, global food security remains under pressure. Hundreds of millions of people continue to experience hunger, while billions more face varying degrees of food insecurity. As populations grow and climate conditions become increasingly unpredictable, ensuring a stable and reliable food supply has become one of the defining challenges of the 21st century. Modern agriculture depends heavily on a relatively small number of crops. Rice, wheat, and maize provide a large share of the calories consumed worldwide. While these crops have helped feed a growing global population, dependence on a limited number of species also creates vulnerability. When environmental conditions change or new biological threats emerge, entire production systems can be placed at risk. One of nature's most powerful responses to uncertainty is diversity. Throughout history, farmers and communities have cultivated thousands of crop species and countless varieties adapted to different climates, soils, cultures, and growing conditions. This diversity represents a vast reservoir of genetic resources that can help agriculture adapt to changing environments. Crop diversity includes the variety of crop species we cultivate, the diversity found within each crop species, traditional farmer-developed landraces, and the wild relatives from which many crops originated. Together, these forms of diversity provide the biological foundation for resilience, adaptation, and long-term food security. In this module, we will explore how crop diversity strengthens agricultural systems, reduces vulnerability to climate-related shocks, supports stable food production, and contributes to resilient food systems capable of meeting future challenges. We will examine the scientific evidence, the role of genetic diversity, the importance of conservation, and the practical strategies being used around the world to build climate-resilient agriculture. Understanding crop diversity is not simply about understanding plants. It is about understanding how biodiversity, agriculture, climate adaptation, food security, and human well-being are interconnected within a complex and rapidly changing world. We will examine diversity at multiple levels, including diversity among crop species, diversity within crop species, traditional farmer-developed varieties known as landraces, and the wild relatives that contribute valuable genetic traits to modern agriculture. You will also learn how climate change affects agricultural systems. Rising temperatures, changing rainfall patterns, extreme weather events, and expanding pest and disease pressures are transforming growing conditions around the world. Understanding these pressures is essential for understanding why resilient agricultural systems are becoming increasingly important. A central theme of this module is the relationship between diversity and resilience. We will explore how biological diversity helps agricultural systems absorb shocks, adapt to changing conditions, and continue functioning even when individual crops or varieties face environmental stress. You will also examine how crop diversity contributes to food security. Diverse agricultural systems can help stabilize production, reduce risk, improve nutrition, and support the livelihoods of farming communities. In a world facing increasing uncertainty, diversity acts as a form of biological insurance that helps safeguard food supplies. Another important objective is understanding the conservation of genetic resources. We will explore why protecting crop varieties, traditional landraces, seed collections, and wild relatives is essential for future agricultural adaptation. These resources provide the raw genetic material needed to develop crops capable of thriving under changing climatic conditions. Finally, we will apply systems thinking to agriculture and climate adaptation. Rather than viewing crops, farmers, ecosystems, and food systems as separate components, we will examine how they interact within a larger system. This perspective helps reveal how decisions made today can influence resilience, sustainability, and food security for future generations. As we move through the module, keep these learning objectives in mind. Together, they provide a framework for understanding how crop diversity supports resilient agriculture and why it is increasingly recognized as a critical component of climate adaptation strategies worldwide. Before we begin exploring the science of crop diversity and climate resilience, it is useful to understand what this module aims to accomplish. Climate change is creating complex challenges for agriculture, food systems, and rural livelihoods. Addressing these challenges requires more than simply understanding individual crops or farming practices. It requires an appreciation of how biological diversity contributes to adaptation, resilience, and long-term sustainability. By the end of this module, you will be able to explain what crop diversity is and why it matters. Crop diversity is one of the most important yet often overlooked foundations of global food security. For thousands of years, farmers have cultivated a wide range of crops and crop varieties adapted to different climates, soils, landscapes, and cultural traditions. This diversity has enabled agriculture to thrive across an extraordinary range of environmental conditions and has provided humanity with the biological resources needed to adapt to change. Today, however, agriculture faces growing challenges. Climate change is increasing temperatures, altering rainfall patterns, intensifying droughts and floods, and expanding the range of pests and diseases. These changes are creating new risks for agricultural production at a time when global demand for food continues to rise. Modern food systems also depend heavily on a relatively small number of crops. Rice, wheat, and maize provide a significant share of the world's food supply. While these crops are essential to global nutrition, dependence on a limited number of species and varieties can increase vulnerability when environmental conditions become unstable. Crop diversity helps reduce this vulnerability. Agricultural systems that contain a wider range of crops and crop varieties are generally more resilient to climatic shocks. Different crops respond differently to environmental stress. When drought, heat, flooding, or disease affects one crop, others may continue to perform well, helping to stabilize production and reduce overall risk. The benefits of crop diversity extend beyond production stability. Diverse agricultural systems often support healthier soils, more effective pest management, greater biodiversity, improved resource efficiency, and more nutritious diets. These benefits strengthen both ecological and social resilience. At the genetic level, diversity provides the raw material for adaptation. Traits such as drought tolerance, heat tolerance, salinity tolerance, flood resistance, and disease resistance are often found within traditional crop varieties and wild relatives. Plant breeders depend upon these genetic resources to develop improved varieties capable of thriving under changing environmental conditions. The conservation of crop diversity has therefore become a global priority. Seed banks, gene banks, botanical collections, research institutions, farming communities, and international organizations are working together to preserve and utilize genetic resources before they are lost through genetic erosion. Protecting this diversity helps ensure that future generations will have access to the biological tools needed to respond to emerging challenges. Research from around the world increasingly demonstrates that crop diversification can strengthen agricultural resilience. Diverse farming systems often experience lower production variability, improved recovery following environmental shocks, and greater capacity to adapt to uncertain future conditions. While crop diversity is not a complete solution to climate change, it represents an important component of broader adaptation and food security strategies. This module explores how crop diversity contributes to climate resilience, examines the scientific evidence supporting diversification, and highlights the role of genetic resources in building sustainable food systems. The central message is straightforward but powerful. Diversity increases options, and in a world characterized by uncertainty, options create resilience. As climate change accelerates and agricultural systems face mounting pressures, preserving and utilizing crop diversity may prove to be one of humanity's most valuable investments in food security, sustainability, and long-term well-being. Food security is one of the most fundamental requirements for human well-being. Every Every society depends upon reliable access to sufficient, safe, and nutritious food to support healthy and productive lives. Yet, despite remarkable advances in agricultural science and technology, food insecurity remains a major global challenge. According to international estimates, hundreds of millions of people continue to experience chronic hunger, while more than 2 billion people face moderate or severe food insecurity. For many households, food availability is not the only concern. Affordability, accessibility, nutritional quality, and stability of supply are equally important dimensions of food security. The challenge is becoming increasingly complex. The global population continues to grow, placing additional pressure on agricultural systems to produce more food from finite land and water resources. At the same time, urbanization, changing dietary preferences, environmental degradation, economic instability, and geopolitical conflicts are influencing both food production and food distribution. Climate change is emerging as one of the most significant threats to food security. Rising temperatures, altered rainfall patterns, prolonged droughts, floods, storms, and extreme weather events are disrupting agricultural production across many regions of the world. These impacts are often most severe in countries that are already vulnerable due to poverty, limited infrastructure, or dependence on agriculture for livelihoods. Food systems are also becoming increasingly interconnected. A drought in one major grain-producing region, a disruption in global trade routes, or a sharp increase in fertilizer prices can affect food prices and availability thousands of kilometers away. As a result, local agricultural challenges often have global consequences. One important source of vulnerability lies in the structure of modern agriculture itself. Although humanity has cultivated thousands of plant species throughout history, modern food systems depend heavily on a relatively small number of crops. Rice, wheat, and maize provide roughly half of the calories consumed worldwide. This concentration has contributed to high productivity, but has also increased dependence on a limited set of genetic resources. When agricultural systems become highly dependent on a small number of crops or varieties, they may become more susceptible to environmental change, pests, diseases, and market disruptions. History provides many examples of crop failures that resulted from insufficient genetic diversity, demonstrating the risks associated with biological uniformity. The challenge facing agriculture today is therefore not simply producing more food. It is producing food in ways that are resilient, sustainable, adaptable, and capable of functioning under increasingly uncertain environmental conditions. Addressing this challenge requires multiple strategies, including technological innovation, improved resource management, climate adaptation, sustainable farming practices, and stronger food systems. It also requires protecting and utilizing one of agriculture's most valuable assets: biological diversity. As we will see throughout this module, crop diversity plays a critical role in helping agricultural systems manage risk, maintain productivity, and adapt to changing environmental conditions. Understanding the global food security challenge provides the foundation for understanding why crop diversity has become such an important topic in discussions about climate resilience and sustainable development. The question is not simply how we feed a growing world population. The deeper question is how we build food systems that remain productive, resilient, and adaptable in a future characterized by increasing environmental uncertainty. Climate change is transforming food systems at every level, from individual farms and local communities to national economies and global agricultural markets. Unlike many other challenges facing agriculture, climate change affects multiple components of food production simultaneously, creating complex and often interconnected risks. One of the most direct impacts is rising temperature. Many crops have specific temperature ranges within which they grow most effectively. When temperatures rise beyond these thresholds, plant growth can slow, flowering and pollination may be disrupted, grain filling can be reduced, and yields may decline. Heat stress can also affect livestock productivity and animal health. Changes in rainfall patterns present another major challenge. Some regions are experiencing more frequent and severe droughts, while others face increased flooding and excessive rainfall. Both extremes can damage crops, reduce yields, degrade soils, and disrupt planting and harvesting schedules. Farmers increasingly face uncertainty not only about how much rain will fall, but also when it will arrive. Extreme weather events are becoming more frequent and intense in many parts of the world. Hurricanes, cyclones, storms, floods, heat waves, and wildfires can destroy crops, damage agricultural infrastructure, disrupt transportation networks, and reduce food availability. Recovery from such events can take years, particularly in vulnerable regions with limited resources. Climate change also influences the distribution and behavior of pests, weeds, and diseases. As temperatures rise and ecosystems shift, many pests are expanding into new geographic areas where crops may have little natural resistance. Disease outbreaks can become more frequent or severe, creating additional challenges for farmers attempting to maintain production. Water availability is becoming an increasingly important concern. Agriculture accounts for a large share of global freshwater use. In many regions, climate change is altering water supplies through changing precipitation patterns, shrinking glaciers, declining snowpacks, and increased evaporation. Competition for water among agriculture, industry, and urban populations is expected to intensify in many areas. The effects of climate change do not stop at the farm gate. Food processing, storage, transportation, distribution, and markets can all be disrupted by climate-related events. Damage to roads, ports, railways, and supply chains can affect food availability and prices far beyond the regions where climate impacts occur. These challenges are particularly significant because food systems are increasingly interconnected. A drought affecting wheat production in one region can influence global grain prices. A fertilizer shortage caused by geopolitical conflict can increase production costs worldwide. Extreme weather affecting transportation infrastructure can disrupt food supply chains across continents. Importantly, climate change does not affect all countries equally. Many of the nations most vulnerable to climate impacts are also highly dependent on agriculture and already face food security challenges. Limited financial resources, weak infrastructure, and reduced adaptive capacity often make it more difficult for these countries to respond effectively to climate-related shocks. The Climate Risk Index provides a sobering illustration of this unequal vulnerability. Over recent decades, extreme weather events have caused hundreds of thousands of deaths and trillions of dollars in economic losses worldwide. The countries most severely affected are often located in the global south, where agriculture plays a central role in livelihoods and national economies. Many of these countries possess fewer resources to recover from repeated climate-related disasters. These realities highlight an important lesson. The future of food security will depend not only on increasing agricultural production, but also on increasing resilience. Food systems must become better able to absorb shocks, adapt to changing conditions, and continue functioning despite uncertainty. This is where crop diversity becomes especially important. Diverse agricultural systems provide farmers with more options for responding to environmental change. Different crops and varieties possess different characteristics, tolerances, and adaptive capacities. As climate risks increase, diversity can help reduce vulnerability and strengthen resilience across food systems. Understanding how climate change affects agriculture provides the context for our next discussion. Understanding the nature of crop diversity itself and why biological diversity is increasingly recognized as one of agriculture's most important adaptation strategies. One of the most important realities of climate change is that its impacts are not distributed equally. While climate change is a global phenomenon, its consequences vary significantly across countries, regions, communities, and even individual households. Some populations possess the resources and infrastructure needed to adapt, while others face much greater challenges. Agriculture sits at the center of this unequal vulnerability. Many of the countries most exposed to climate risks are also heavily dependent on agriculture for employment, income, and food security. In these regions, climate-related disruptions can affect not only food production, but also livelihoods, economic stability, and social well-being. Geography plays an important role in determining vulnerability. Countries located in arid and semi-arid regions are often highly exposed to drought. Coastal areas face increasing risks from sea level rise, storm surges, and saltwater intrusion. Mountain regions may experience changes in snowpack and glacier melt that affect water supplies for agriculture. Small island states face a unique combination of climate-related threats that can affect both agricultural land and freshwater resources. Economic capacity is another critical factor. Wealthier nations generally possess greater resources to invest in irrigation systems, climate-resilient infrastructure, agricultural research, early warning systems, insurance programs, and disaster recovery efforts. Poorer countries often have fewer options available and may struggle to recover from repeated climate shocks. This difference in adaptive capacity helps explain why climate change frequently has its most severe impacts in regions that have contributed the least to global greenhouse gas emissions. Many developing countries face a double burden. They are highly exposed to climate risks while simultaneously possessing limited resources to manage those risks. The Climate Risk Index provides important insights into this unequal vulnerability. Over the period from 1995 to 2024, more than 832,000 people lost their lives and economic losses exceeded $4.5 trillion as a result of extreme weather events. Floods, storms, droughts, and heat waves have caused enormous human suffering and economic damage across the world. However, the impacts have not been evenly distributed. The countries most affected by extreme weather events have frequently been low-income and lower-middle-income nations. Many of these countries are located in the global south and depend heavily on agriculture as a source of employment and national income. Their lower levels of infrastructure, financial resources, and institutional capacity often make recovery more difficult following climate-related disasters. Climate change can also create vulnerability within countries. Smallholder farmers often face greater risks than large commercial producers. Women farmers, indigenous communities, and rural populations may have less access to land, credit, technology, extension services, and climate information. These inequalities can amplify the effects of climate-related shocks and reduce the ability of communities to adapt. Food insecurity further compounds vulnerability. When households already struggle to access sufficient food, even relatively small declines in agricultural production can have serious consequences. Crop failures, livestock losses, rising food prices, and reduced incomes can push vulnerable populations deeper into poverty and food insecurity. Climate scientists increasingly emphasize that climate change is not only increasing the frequency of certain extreme weather events, but also increasing their intensity. Heat waves are becoming more severe, droughts are lasting longer, rainfall events are becoming more intense, and storms are causing greater damage. What were once considered rare events are becoming more common features of the agricultural landscape. These trends highlight the importance of resilience. Communities that depend on a narrow range of crops or agricultural activities often face greater risk when environmental conditions change. In contrast, systems that incorporate greater biological diversity, multiple crops, and a wider range of adaptive options are often better positioned to withstand uncertainty. This understanding leads directly to one of the central themes of this module. If climate change creates unequal vulnerability, then building resilience becomes a priority. Crop diversity represents one of the most important biological tools available for strengthening resilience because it expands the range of options available to farmers, communities, and food systems facing an uncertain future. The challenge is not simply to survive climate change. The challenge is to build agricultural systems capable of adapting, recovering, and continuing to provide food and livelihoods despite increasingly complex environmental pressures. For much of human history, farmers have adapted to seasonal variability. They learned to work with predictable patterns of rainfall, temperature, and growing seasons that shaped agricultural production from one generation to the next. While weather has always varied from year to year, the underlying climate remained relatively stable. Today, that stability is changing. Climate scientists increasingly describe the world as entering an era of heightened climatic uncertainty. Events that were once considered rare are becoming more frequent, more intense, and more damaging. Heat waves, droughts, floods, storms, wildfires, and extreme rainfall events are occurring with greater regularity across many regions of the world. The phrase "the new normal" reflects an important reality. Extreme weather events are no longer isolated anomalies. They are becoming a recurring feature of the global climate system and are increasingly influencing agricultural production, food security, water resources, infrastructure, and human livelihoods. Heat waves provide a striking example. Rising global temperatures mean that many regions are experiencing more days of extreme heat than ever before. High temperatures can reduce crop yields, accelerate soil moisture loss, increase irrigation demands, and place livestock under significant stress. During critical growth stages, even a few days of extreme heat can substantially reduce agricultural productivity. Droughts are also becoming more severe in many agricultural regions. Reduced rainfall combined with higher evaporation rates can lead to water shortages, declining soil moisture, lower crop yields, and increased competition for water resources. Prolonged droughts can have cascading effects on food production, rural livelihoods, and national economies. At the other extreme, excessive rainfall and flooding can be equally destructive. Heavy precipitation can damage crops, erode soils, delay planting and harvesting operations, destroy infrastructure, and contaminate water supplies. In some regions, farmers now face the paradox of experiencing both drought and flooding within the same growing season. Storms and tropical cyclones are causing increasingly costly damage to agricultural systems. Strong winds, storm surges, and intense rainfall can devastate crops, livestock operations, storage facilities, transportation networks, and rural communities. Recovery often requires substantial investments and may take years to complete. Wildfires have emerged as another growing threat in many parts of the world. Higher temperatures, prolonged droughts, and changing vegetation patterns have increased fire risks across large landscapes. Wildfires can destroy agricultural land, orchards, grazing areas, forests, and rural infrastructure, while also affecting air quality and human health. The Climate Risk Index illustrates the scale of these impacts. Between 1995 and 2024, more than 9,700 extreme weather events were recorded worldwide. These events contributed to over 832,000 deaths and direct economic losses exceeding $4.5 trillion. Floods, storms, droughts, and heat waves were among the most significant contributors to human suffering and economic damage. Climate science also shows that human-induced climate change is increasing the likelihood and intensity of many extreme weather events. Research indicates that climate change is no longer a future concern. It is already influencing weather patterns around the world. In 2024 alone, billions of people experienced prolonged periods of extreme heat, and many regions recorded their hottest temperatures on record. For agriculture, this trend creates a fundamental challenge. Farming systems developed under historical climate conditions may no longer perform reliably under future conditions. Traditional assumptions about planting dates, growing seasons, water availability, and crop performance are becoming less certain. This is why resilience has become a central concept in climate adaptation. Resilience refers to the ability of a system to absorb disturbances, adapt to changing conditions, and continue functioning despite shocks and stresses. Agricultural systems that depend heavily on a small number of crops or varieties may face greater risks when extreme weather occurs. In contrast, systems that incorporate greater diversity often possess a broader range of responses to environmental stress. Different crops and varieties react differently to drought, heat, flooding, pests, and diseases. Some may fail under certain conditions, while others continue to produce. Diversity therefore acts as a buffer against uncertainty. As extreme weather becomes the new normal, agriculture must move beyond simply maximizing production under ideal conditions. The goal increasingly becomes maintaining productivity under variable and unpredictable conditions. This shift in thinking brings us directly to one of the most important concepts in this module: understanding crop diversity and why biological diversity provides one of nature's most effective mechanisms for coping with environmental uncertainty. Let's pause to test our understanding of the lesson. Which three crops provide a large share of global dietary calories? Rice, wheat, and maize provide a large share of global dietary calories. Dependence on a limited number of crops increases vulnerability to environmental and biological shocks. Which climate-related factor can directly reduce agricultural productivity? Heat stress can disrupt plant growth, flowering, pollination, and grain development. Why can reliance on a small number of crops increase food system risk? Reliance on a small number of crops reduces adaptation options. Agricultural systems become more vulnerable when biological diversity is limited. Apply the lesson to your own context. Which climate-related challenge do you believe poses the greatest threat to food security in your region? Consider this scenario. A region depends heavily on a single crop. A drought causes major production losses and food prices rise. What vulnerabilities within the food system may have contributed to this outcome? Several vulnerabilities contributed to this outcome. Dependence on a single crop reduced resilience. Greater diversity could have spread risk and improved adaptation options. In Lesson 2, we will examine crop diversity itself, exploring the different forms of diversity that support agricultural adaptation and resilience.